Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime. And all you need to do is write some JavaScript code and use the real-time web with Node.
You're watching Real-Time Web with Node, and you've made it to the final level, level 7, where we're going to be talking about persisting data. So back in our chat app, if we say hello, anyone out there? And then somebody else joins, connects to the server. It's of course Spider. Who else would it be? They're not going to see any of our previous messages, but that's typically not how chat applications, how you want them to work. So let's figure out how we might persist these messages as they come in so that new people who join see the previous couple messages. You'll notice here's our old code. We're on join, we're setting the nickname, we're broadcasting who joined the chat, and then on messages, when a new message comes in on the server side, we emit it to everybody else, and we also emit it back to us. So let's jump in here. What we might do to store the messages is create a messages array on the server side where we're going to put all the messages. Then we'll create a store messages function. This function takes the name of the person who sent the message and what they sent, and then we'll simply push onto the messages array an object with the name and the data, which is the message. Then if our messages is greater than 10 in length, we'll go ahead and shift one off, shift the first one off, so there will only ever be 10 previous messages. Then down below in the messages listener, after we get done emitting the messages, let's store that message that we just received. We're storing all the messages as they get received, but we need to go back into the join listener so that when a new client joins, we iterate through each of the messages, like you see here, and emit to that client that just joined all the messages, so it'll display them onto their screen. So if we jump back into our browser and we type a couple messages and we connect a new client, we can see that all the messages are there waiting for us. Now let's exit our server and restart it and go back into our browser. As you can see, now that we've restarted our server, our messages array got blanked out and our messages aren't there anymore. So we need to think about how we could persist those messages even if our server restarts. One way to solve this problem is to use a database of some sort. Luckily, Node works great with all sorts of databases, from Mongo to Couch to Postgres, Memcache, Riak, Redis. They all play well with Node, and they all have non-blocking drivers. Lots of times in other languages that use these databases, you'll find they have drivers that are blocking. That means when you go to submit a SQL request, well, your process kind of just hangs there, can't process anything else while it's waiting for the database to return. Kind of crazy. Well, Node, of course, everything we write is non-blocking. So that means you could have two queries and they both submit queries to the databases, and your process can do other stuff while it's waiting for these two queries to come back and then call the callbacks and then do more stuff. Pretty neat. So let's jump into Redis. And luckily, Redis has all sorts of data structures that we can store inside of its database, from strings to hashes to lists to sets to sorted sets. We're going to be using strings, lists, and sets. Now, Redis has a great home page. It makes it really easy to start playing with the different components and different data structures. So if we go into the documentation here, the different commands, and we look under strings, we can see that we can use get. We can even start playing with it right here in the browser. So we can say something like set new key to set a value. We'll set the value dog. And then if we get new key, we're getting back dog. So new key is our key, and then dog was our value. Now let's jump into lists. We're going to be using the lpush list command. We can check out the syntax, and then we can start pushing things onto a new list. So let's give that a try. We'll push onto our new list dog, we'll push onto our new list cat, and then we'll use the lrange command to get back the values out of it from 0 to -1, giving us all the values in the list. To connect our Node application with Redis, we're going to be using the Node Redis library. This is where you could find it on GitHub. To install it, we call just npm install redis -- save so that we can install it and add it to our package.json. Then inside of our code, we simply require Redis. Then we can create a Redis client by calling redis.createClient. Then we can start issuing commands to the database. We can call set message 1, hello, this is dog, set message 2, hello, no, this is spider. So we're setting the keys and the values. To get the messages out of the database, we simply call get, and we send in a callback. This goes with that non-blocking thing. We're going to get this out of the database, but while it's fetching it, we can go off and do other stuff, and then when the value comes back from the database, it will invoke this callback function and log it out to the console. If we want to store a list in the Redis database, we could create a message and lpush, left push, onto the messages list, this current message, and then specify a callback here. This callback is optional, but it sends back in the reply variable here the list length in case you need it. If we add another string to messages, we can see here that it returns the length of 2. Instead of logging out the length of the array to the screen, we're going to use the ltrim function. The ltrim function, in this case, we're going to send in 0 and 1. It's going to keep the first 2 strings in the array and remove the rest. If we want to retrieve the values from the list, we can use lrange. Remember, we saw that before, sending in 0 to -1, which will return all the elements in the list. If we log them out to the console, here's what we would get. If we jump back into our old code, you can see here's our store message function, and we need to rewrite this to use Redis. First, we need to create our Redis client, and then inside of our store function, we need to take the name and the data that we send in, put them into an object, and then call JSON stringify, which will turn that object into a string we can easily store in Redis. Then we'll call lpush, send that in as the message, and then call ltrim, so it'll keep the newest 10 items in the array. Here's our old join listener, where we're iterating through all the messages when somebody joins and printing it out to the screen. We'll modify this code to use Redis, first fetching all of the list items with lrange. Then we'll reverse the messages so they're emitted in the correct order. Then we'll iterate through each message that gets returned in that list. First, parsing the string that gets returned into a JSON object, and then finally emitting that to the client. Here we are back in our browser. We say, hello everyone, it's me. Now if we connect another client, and they type in their name, we'll see it properly loads our list from Reddit and broadcasts it into our browser. If we exit our server and restart it, if we open up a new client, give it a new nickname, and we can see it's properly loaded all the old messages from Redis, even though we restarted our server. There's one more thing we need to do to create this chatter application, and that's to show a list of who is currently in the room, who is connected. We're going to do that using a set. Sets are lists of unique data. You can't have duplicates. And to store a set in Redis, we're going to call sadd, and then specify the set name, in this case names, and then the value we want to send into the set, in this case dog, and then spider, and then Greg. To remove an item, we simply call srem for remove, and send in the set name and the value we want to remove. Then to list out all the members of a set, we call smembers, sending in the name of the set, in this case names, and then we'll specify what to do when the set gets returned, in this case log it out to the console. Now we need to jump back into our join event listener on our server. When somebody joins, the first thing we need to do is we're going to emit the add chatter event. We're going to broadcast it to all of our clients so we can add that chatter. Then we need to add this chatter to our Redis set. We're going to call the set chatters. Now back in our client, we need to define the add chatter listener. And this will invoke a callback that receives the name of this new chatter. And here we'll simply build a new jQuery element with the new chatter's name and then append that to the chatters element. So we add this new chatter when they join and we let everyone know about it. But what if there's already chatters in the chat room? What if there's already users in our set? We need to check for that. So we'll use our Redis client to list out all of the people in our set, well, all the names, and then on that callback, we'll iterate through each of the names, and then on our client, which just connected, we'll emit add chatter and send in each name. Last thing we need to do is remove a chatter when their WebSocket disconnects. So we'll say on the disconnect event, get their current nickname, broadcast the remove chatter event to all of our other clients, and then remove them from our Redis set. Then on the client side, we need to listen for that remove chatter event, and when that gets called, we'll simply use some jQuery to remove it from the list. So now if we jump back into our browser, we can send in a message. You'll notice dog is already connected. We'll start up a new client. And look, we can see that both Spider and Dog are connected users. Let's even connect another client. So here we'll connect Greg and we can see that all three people are in the room and everybody can see who is chatting. All right, we have a chatter application. It's a real-time web node application. And now it's time for you to get into some of those last challenges, and I'll see you in the outro video. Good luck.